Well, again, we are continuing with the Newton's laws of motion, but today's topic of discussion will be basically the applications of pulley and inclined plane. When we speak of pulley, it is a solid block in the form of a triangle, solid or triangular block, and angle of inclination is generally known as the angle of inclined plane. And in pulley, we take a string, pass over the pulley, and to the two free sides of the string, we adjust the masses. So how the masses move, what will be the tension on the string, what will be the acceleration of the masses, these facts we have to go through. And inclined plane, a block will be kept on the plane, the weight will act vertically down, that will be mg, and the surface of the inclined plane will apply the normal reaction on the block, and the weight mg will be resolved into two components. Then in the direction opposite to r, the component will be mg cos theta, and the component of the force along the inclined plane will be mg sine theta. Wherever we write mg, we take it as force. So these facts we have to apply in some of the questions, that is some examples, and we have to check up their solutions. If we consider a string passing over a pulley, the weight will be always acting vertically down, and that weight will be mg, and tension will always be on the pulley. So T and mg will be equal. If the weight is coming down, then we have to take the difference of the two forces. That is, mg minus tension must be equal to ma. And if the weight is going up, then it is T minus mg will be equal to ma. The acceleration of the masses will remain same because the string is not changing. There is only one string having two free ends. So tension will also not change. If the tensions in the string will be upward, the tension in the pulley will be downward, and that will be double the tension on the strings. So these facts we have to apply in pulley and inclined plane. Now, in our first example, our question is the pulley arrangement of figures A and B. So you can see figures A and B. The pulley arrangements of figures A and B are identical. The masses of the rope is negligible. In figure A, the mass M is lifted by attaching a mass to M. So in figure A, if we find towards the right side it is 2M, and towards the left side it is M. Obviously 2M is greater than M, so tendency of the mass will be to move downward, that is 2M will come down and M will go up. However, the tension in the two strings will remain the same, and acceleration of the two masses will be same. Now, in figure A, the mass M is lifted by attaching a mass 2M to the other end of the rope, as I have just explained you. In figure B, mass M is lifted by pulling the other end of the rope with a constant downward force, and that force is 2mg. That is, normally force will be weight. So what we have done is 2m is multiplied by g. If g will not be provided, we can take its value as 9.8. If its value is not given, it will be 10, and if it is given, obviously we have to take 9.8. Now to solve this question, we will find that tension in the string with T and acceleration is A. As I have explained to you, neither T will change nor A will change. Now, T minus mg is equal to ma. This is applicable to one side of the string where mass is going up. So we will say T minus mg is equal to ma. This is the first equation. And towards the right string, we will find 2m is coming down. So it should be 2mg minus T is equal to 2ma. Now we got two equations. And if we solve these two equations by substitution and elimination, we can get the value of acceleration of the masses. So some of the numbers will cancel off and the net result will be A is equal to G over 3. If G is 10, then 10 is divided by 3 and that will be 3.3 and that will be in meters per second square. Now, suppose that in case shown in figure B, the tension in the string is T dash, acceleration of the masses be A dash, then T dash minus mg will be equal to ma dash. So here we have slightly changed the notation. We have written T dash and A dash. We formed equation number 3 and we can write now T dash minus 2mg must be 0. T dash minus 2mg will be 0. That is equation number 4. And now what we will do from third and fourth equation. In the third equation, it is T dash minus mg is equal to ma dash. And in the fourth equation, it is T dash minus 2mg is equal to 0. So, excluding T dash, the numbers will be taken towards the right side. So, we get two values of T dash, we equate them, and we come to conclusion that A over A dash will be equal to G over 3 over G, because A is calculated from first and second equation as G over 3 and A dash is equal to G. So by equating these two numbers, we will find the acceleration is 1/3 of A dash, or A dash will be equal to 3 times the acceleration in first case. Now we come towards the second example. A body of mass 10 kg as shown in the figure. Mass 10 kg is lying on the surface of the table, placed on a horizontal smooth table. And in all such calculations, we have to assume that surface is perfectly frictionless and there is no obstruction to the masses. That we assume. However, practically that's not possible, because always there is some friction and obstruction of air is always existing. So our assumption is that there is a frictionless pulley, surface frictionless, no obstruction to masses. Now our statement is that the body of mass 10 kg is placed on horizontal smooth table as shown in the figure. A string is tied with it which passes over a frictionless pulley. The other end of string is tied with a body of mass 5 kilograms. When the bodies move, then we have to find the acceleration produced in them. Now we are finding m1 mass is 10 kg, m2 mass is 5 kg. So due to gravitational force, 5g acting on the body of mass 5 kg. So when we say mass is 5 kg, its weight will be 5 into g. Now 5 into g means 5 multiplied by 9.8 or 5 multiplied by 10. If g is not given, both bodies move. Let the acceleration produced in the system be A, then m2g. m2g means weight of body with 5 kg weight. So force is mass into acceleration. Here the total masses will be m1 and m2. So we have taken m2g is equal to m1 plus m2 multiplied by A. Now from this equation, we will make the subject of equation as A, and A will be calculated by function m2g over m1 plus m2. m2g represents the weight or the force. So for that we will put the value as given. m2 is 5 and g can be taken as 9.8. So 5g over m1 plus m2 will be 15, that is 10 plus 5. So 15 is cancelled off by 5. So the number comes as g over 3, and finally it will be 9.8 over 3. That is calculated out as 3.27 meters per second square. So what exactly we have to find? We have to find the acceleration produced in that. So acceleration produced in the masses, that is 3.27 meters per second square. We can write up to 1 decimal place because 2 is not significant. So we can remove 7 and we can add 1 to 2. So the net result can also be expressed as 3.27 or 3.3. meters per second square up to 1 decimal place.